Internal combustion engine. In this topic, we will understand how a four-stroke internal combustion engine works. Most of the automobiles work on four-stroke internal combustion engines. Here, fuel combustion occurs inside the engine, thereby giving its name internal combustion engine. It was designed by Nicholas Otto in 1876, and hence is also called an Otto engine. Construction. A four-stroke engine mainly consists of insulated airtight cylinders with movable piston, which are joined to the crankshaft through connecting rods. The intake valves let the fuel-air mixture enter the cylinder. Spark plug produces spark and ignites the fuel-air mixture, and the exhaust valves allow exhaust gases to exit the cylinder. Camshafts control the opening and closing of valves at appropriate times. Camshafts are connected by timing chain with the crankshaft to maintain synchronization between their motions. And a jacket surrounds the cylinder bank, through which cold water is continuously circulated to absorb excess heat produced during combustion. Working of an ideal four-stroke engine. The four-stroke engine is given its name because every cycle of this engine consists of four strokes, that is, intake stroke, compression stroke, power stroke, and exhaust stroke, which keep repeating one after the other. The PV diagram gives us the graph of pressure versus volume during each engine cycle. The engine cycle begins when the piston is at its top position, called top dead center or TDC, and both the valves are closed. Intake stroke. During this stroke, the intake valves open and the fuel-air mixture, called charge, enters the cylinder at near atmospheric pressure. The piston descends from TDC towards the bottom dead center, or BDC, of the cylinder, and the volume of charge increases. As the intake valves are open, the pressure and temperature of charge inside the chamber remain constant. When the piston reaches BDC, intake valves close. The cylinder is full of fuel-air mixture at atmospheric pressure. Compression stroke. The piston moves upwards in the cylinder with both the valves closed. So the fuel-air mixture is compressed and its volume reduces. The compression causes an increase in pressure and temperature of the gases in the cylinder. Just before the piston reaches the TDC, the spark plug produces spark and the fuel explodes. Rapid combustion in the closed cylinder increases the temperature immensely. The pressure in the combustion chamber increases to a very high value with almost no change in volume. Power stroke. During this stroke, since both the valves are closed, the increased pressure acts on the face of the piston. So, the piston moves down towards BDC. As a result, volume occupied by the gases increases. As no heat is transferred to the cylinder, the pressure and temperature of the gases decrease. The work done on the piston is transmitted by the connecting rod to the crankshaft, where the linear motion of the piston is converted into rotational motion of the crankshaft. This is the only stroke during which power is produced from the fuel to obtain mechanical energy. Hence, it is called the power stroke. When the piston reaches the BDC, the power stroke ends. Exhaust stroke. During this stroke, the exhaust valves open. Consequently, the pressure suddenly falls to atmospheric pressure with almost no change in volume. The piston now moves towards TDC, forcing the exhaust gases out of the cylinder. The volume occupied by the gases decreases at constant atmospheric pressure. When it reaches TDC, the exhaust valves close, completing one engine cycle. These 4 strokes of the engine cycle keep repeating, and the engine continues to work, enabling the vehicle to continue its motion. Summary: the internal combustion engine invented by Nicholas Otto converts the energy of a fuel-air mixture into mechanical energy by burning it within a combustion chamber. And the engine cycle of an internal combustion engine consists of 4 strokes, namely intake stroke, compression stroke, power stroke, and exhaust stroke. It is called a 4-stroke engine.